As we keep on trying to understand more about the universe, we're looking at things that go way beyond what we can imagine. From the vast reaches of deep space to the very birth of stars, we're looking for answers to questions that are fundamental to existence. And now, in an unexpected turn of events, we've encountered something that might just challenge our entire understanding of the universe. Something that could be older than the universe itself. How could something like this even exist? Could it be that everything we thought we knew about the Big Bang Theory is wrong? Or could it be that our universe is actually much older than we ever thought? Today, we're looking at one of the most intriguing cosmic puzzles yet. The James Webb Space Telescope has recently captured something extraordinary with its sharp and steady gaze. It spotted a structure in the deep space that seemed to have been around before the stars even formed. This ancient celestial object, located about 390 light-years away, seems to have existed before the Big Bang, which is thought to be the moment the universe was born. Just to give you some context, 1 light-year is about 6 trillion miles, so this discovery raises some pretty profound questions. How could something exist before time as we know it began? Was the Big Bang Theory wrong all along? Or is there another explanation that we just don't know about yet? As we grapple with this mind-bending mystery, let's take a step back and consider another ancient star closer to home. About 200 light-years from Earth, near the Libra constellation, is an ancient stellar traveler called HD 140,283. This star, often called the Methuselah star, is an astonishing 14.46 billion years old, making it one of the oldest stars we've ever found. Here's the thing, it's thought that our universe is only around 13.8 billion years old. How can a star be older than the universe itself? To get to the bottom of this, let's first take a look at how we determine the age of stars. It's really tricky to date stars like our sun. Just picture trying to work out how long a light bulb has been shining by looking at it. It's pretty tricky, isn't it? That's because stars stay bright and big for billions of years. But astronomers are clever cookies. By keeping an eye on how bright and colorful a star is over time, we can create models that show how stars change over time. One key piece of information comes from how quickly a star spins. Stars, much like wheels, slow down over time due to the cosmic equivalent of friction. By comparing how fast stars are spinning at different ages, astronomers can use a technique called gyrochronology to estimate how old they are. We can also work out how old a star is by looking at its magnetic activity. Younger stars tend to have a lot of energy and flare up quite a bit like an enthusiastic child. Older stars, on the other hand, are more calm and subdued. By looking at these changes in magnetic activity, astronomers can work out how a star has behaved over time. And then there's asteroseismology, which is a method where scientists listen in on a star's internal vibrations. These ripples, caused by waves traveling through the star's interior, help us to work out how old it is. For instance, we've used these techniques to work out that our sun is about 4.58 billion years old. Let's go back to the Methuselah star. This ancient star has stumped scientists for years. The initial estimate was a whopping 16 billion years old, which is over 2 billion years older than the universe itself. After recalculating, astronomers adjusted its age to around 14.46 billion years, with a margin of error of around 0.8 billion years. But even that's too old, given the universe's supposed 13.8 billion year age. How could this be? It could be that we find the answer in how stars are formed. Our sun is part of a group of stars known as population 1 stars, which are rich in heavy elements like iron. The Methuselah star, though, is a population 2 star, which formed early in the history of the universe with far fewer heavy elements. By looking at the chemical makeup of stars, astronomers can roughly work out when they formed. The fewer heavy elements a star contains, the older it is likely to be. But there's more. There's a hypothetical group of stars known as population 3, which are thought to be the first stars ever formed after the Big Bang. If they existed, these stars would have almost no heavy elements at all, consisting almost entirely of hydrogen and helium. We haven't yet observed any of these primordial stars, but they likely played a critical role in the early universe by seeding the cosmos with heavier elements when they exploded in supernovae. So where do we stand with Methuselah star? Is it genuinely older than the universe? Or is there something else going on? One possibility is that we don't really know how old the universe is. After all, the current estimate of 13.8 billion years is based on our observations of the cosmic microwave background, which is the faint afterglow of the Big Bang. By studying how this ancient light has stretched over time, scientists have been able to work out how fast the universe is expanding and therefore how old it is. But there's a growing possibility that this method might not give the full picture. New research from the University of Ottawa suggests the universe could be much older than we thought, possibly as old as 26.7 billion years. Professor Rajendra Gupta suggests a new approach that combines our understanding of an expanding universe with an older idea called the tired light hypothesis. This theory, which was first proposed by Swiss astronomer Fritz Zwicky in 1929, suggests that as light travels through space, it loses energy over time. If Gupta's hypothesis is right, it could explain why the Methuselah star seems to go against the cosmic clock. To make things even more interesting, Gupta adds another idea to the mix by talking about changing coupling constants. This idea was first suggested by theoretical physicist Paul Dirac, who said that the way particles interact has changed over time. If this is true, it could mean that the very laws of physics have changed along with the universe, allowing for a much older cosmic timeline than we've imagined. Let's not get ahead of ourselves just yet. While these ideas are certainly interesting, they're still up for debate. Scientists have been working for decades to refine our understanding of the age of the universe, and we've made a lot of progress since the early 20th century. Back in the 1920s, astronomer Edwin Hubble thought the universe was only 2 billion years old. As our observational techniques improved over time, we revised that number upwards. It wasn't until the late 1990s that we finally got the current estimate of 13.8 billion years right. Is it really possible that we could be off by as much as 13 billion years? Even if the universe is older than we thought, that wouldn't take away from the importance of discoveries like the Methuselah star. Even if the universe is older than we thought, it would still be one of the oldest known stars in the universe, a relic from an era when the Milky Way was still forming. The Methuselah star gives us a fascinating insight into the early universe. This was a time when our galaxy was absorbing smaller, dwarf galaxies, and star formation was at its peak. This brings us to another cosmic puzzle. While we're focused on understanding the age of stars in the universe, there's an even bigger mystery lurking in the shadows: dark matter. Dark matter is an invisible substance that makes up roughly 85% of the mass in the universe. We can't see it, but we know it's there because it exerts a gravitational pull on galaxies and stars. This is where it gets really interesting. Recent measurements indicate that stars on the outskirts of our Milky Way are moving at a slower pace than anticipated. This challenges what we've seen in other galaxies and suggests that our galaxy might be missing some dark matter. For decades, astronomers have assumed that dark matter surrounds galaxies in massive halos. But new data from the European Space Agency's Gaia satellite is forcing us to rethink this assumption. The Gaia satellite is mapping the positions and motions of nearly 2 billion stars in our galaxy, and it's provided some incredibly detailed data on how stars move. And it seems that the data is showing something unexpected. The stars on the outer edges of the galaxy are moving more slowly than we thought. This has led astronomers to estimate that the Milky Way might be as much as 5 times lighter than we previously thought. But why does this matter? Well, understanding where the dark matter is in our galaxy is crucial to solving the larger puzzle of how galaxies form and evolve. If the Milky Way has less dark matter than we thought, that could mean our entire model of galaxy formation needs to be rethought. It's like finding out that your favorite recipe has been missing a key ingredient all along. It's been known for a long time among astronomers that dark matter plays a big part in how the universe's gravity works. Back in the 1970s, Vera Rubin and her colleagues made a big discovery when they noticed that stars at the edge of galaxies were moving just as fast as those near the center. This challenged the predictions of Newtonian physics, which suggested that stars at the edge of a galaxy should move more slowly, like planets in our solar system. Vera Rubin's work showed that there must be something we can't see, dark matter, that gives these galaxies the extra gravitational pull they need to stay together. Yet here we are, decades later, still trying to figure out exactly what dark matter is. Could it be that our current understanding of this invisible substance is flawed? Some scientists now believe this to be the case. If the recent findings from Gaia stand up to scrutiny, It could mean that dark matter behaves differently than we thought, or that there's less of it in the universe than we thought. One thing is for sure, the universe is full of surprises. Whether it's stars that seem to predate the universe itself, or galaxies missing their share of dark matter, these mysteries show us that we're only scratching the surface of cosmic knowledge.